Good morning, sir. I am Bindu KR. Our topic is problem salesman, traveling problem salesman. Introduction to traveling salesman problem. The traveling salesman problem is the challenge of finding the shortest path or shortest possible route of a salesperson to take given a starting point, a number of cities, and optionally on ending point. It is a well-known algorithmic problem in the field of computer science and options research with important real-world applications for logistic and delivery businesses. In theoretical computer science, the TSP commanded so much attention because it is so easy to describe, it's so difficult to solve. The TSP is known to combinatorial optimization problem, that is on NP hard problem, which is means that the number of possible solutions sequences grows exponential with the number of cities. Problem set. For example, consider the graph shown in figure. On the right side, a TSP4 in the graph is 1 to 2, 2 to 4, and 4 to 3, and 3 to 1. So that is equals to 80.
Greetings everyone. Now that we know what traveling salesman problem is, we'll be explaining the different methods to solve the traveling salesman problem. So there are different approaches to solve the traveling salesman problem, but here we will be considering three approaches, that is brute force approach, greedy approach and branch and bound method. Mainly we'll be focusing on brute force approach. So the brute force approach is also known as naive approach. It calculates all the possible permutations or routes of a path to determine the shortest unique solution. So what it does is it does all the permutations of all the possible paths that the traveling salesman can take, and then it saves the minimum path, that is the optimal solution that has to be taken. But the problem with brute force approach or naive approach is that it is feasible for smaller problems only. That is because the time complexity of brute force approach is O of n factorial. When we consider this for smaller numbers such as 3 or 4, 5, even 10, it looks small. But when we are considering real world examples, this number becomes 100 or even thousands. So in that case, the time complexity is very large. So this is the algorithm. So for this we will be considering this example. So here, as we have taken this graph, so what it will do is it will consider one city as the starting and end point. So we will be considering city 1 as the starting and end point. So we'll be generating n minus 1 factorial permutations, that is 4 minus 1 3 factorial, which is 6 permutations. So those permutations are 1 to 2, 2 to 3, 3 to 4 and 4 to 1. Length is 95. Then the second permutation is 1 to 2, 2 to 4, 4 to 3, 3 to 1. The length is 80. Then 1 to 3, 3 to 2, 2 to 4 and 4 to 1. The length is 95. Similarly, we'll be considering 3 more permutations and we'll drag the minimum cost of all those permutations, and we will return the one with the minimum cost. So this will be the output, the lengths of all the possible solutions. So this is the code for our naive method. So here we are taking a traveling salesman problem named function, and we are passing an int named graph and another int named s, which is nothing but the first vertex. So here we are initializing a vector named vertex, and we are pushing all the vertices except the first vertex in this vector. Then we are initializing another variable called minimum path, which will save the minimum length of the graph, and we are initializing it the value of maximum integer value possible. So here is a do while loop which will calculate all the possible permutations of the graph, as well as their respective cost or lengths, and we'll return the minimum path length. And in the main function, this is the graph, that is this same graph represented in the matrix format, and s is the first vertex, and we are returning the optimal solution. So this will be the output. Now we'll be explaining a greedy approach. Greedy approach iteratively selects the nearest unvisited city from the current city, forming a tour. Starting from a city, it continuously moves to the closest unvisited city until all the cities have been visited. So, taking this example again, if we are selecting one as the starting city, then it has three options, either 2, 4, or 3. It will select the city with the minimum or least distance, that is 2, and then 2 has two options for unvisited cities, that is 4 and 3. So the nearest is 4, and then from 4 it has nowhere else to go but 3. And now, since all the nodes have been traveled, it will go back to the initial node, that is 1. The characteristics of greedy approach are simple and fast, since it is not calculating all the possible permutations, and it's only taking the optimal path. So it will be faster than the knife method, and it has local optimicity, that is, it is locally optimized, since it is making decision for each node and not for the whole graph. For example, if it goes on 2, it will only make decision based on what is available to it from 2. It won't make decision from for the whole graph.
So now we are discussing the third approach, that is branch and bound method. Let's start how actually the branch and bound technique is. The branch and bound technique starts by creating an initial route, typically from starting point, the first node in set of cities, that is cities or nodes, whatever we take. Then it systematically explores the different permutations to extend the route beyond the first pair of cities, one node at a time. The major point here is in branch and bound, one bound at a time goes. Let's start if from 1, it can travel only 1 at a time. Let it be 2, or let it be 4, let it be 3. Each each time a new node is added, the algorithm calculates the current path length, compares it to the optimal route found so far. If the current path is already longer than the optimal route, it bonds or puns that the branch is exploration as the world not leads to the more optimal solutions. So here it compares with 1, 1 to 2, 2, 2 to the next one. Optimal path solution it finds. So coming to the disputing is key to making the algorithm efficient by discarding unpromising path. The search space is narrowed down, and the algorithm can focus on exploring only the most promising path is narrated. So the process continues until all the possible routes are explored and the shortest one is identified as the optimal solution to the traveling salesman problem. Branch and bound is an effective greedy approach for tackling NP hard optimization problem like traveling salesman problem. Here what it says is from approach going from one node to other node, 1 to 2, 2 to 3, 3 to 4, 4 to 1. The algorithm actually starts from 1, 1 to 2, 2 to 3, 3 to 4. So what are the major advantages of branch and bound method? So let's discuss. It is more efficient than brute force approach, as we discussed. So apart from that, it is furnaces the unnecessary branches, reducing the compulsions. It stops the unnecessary usage of the other branch. One to two, it can explore the four, or it can explore the three. The efficient way is one to two, reaching in shortest path. The major disadvantage or limitations of this algorithm is more complex implementation. You find more complex implementation from traveling 1 to 2, 2 to 3. Second, the performance depend upon the quality of initial route to the final route. From 1, 1 to 2, 2 to 3, 3 to 4, or 4, 4 to 3, 3 to 2, 2 to 1. Initial to final route. The brute force approach is suitable for only specific, like small data sets and becoming impartial. So apart from that, we could say in small data centers, but the greedy approach is faster but may produce suboptimal solutions. Now we'll go to the real world applications of traveling salesman problem. So what are the real world applications of traveling salesman problem? So the traveling salesman problem applications are major usage of vehicle routing. The vehicle routing, it comes under logistic and transport. In that subdomain, the optimal use of delivery and transportation routes. For let's example, in Amazon, the usage of tracking delivery boy or delivery partner to the respective delivery customer or end user. So apart from that, circuit designing, that is manufacturing and supply chain. So the major real world application in the field of electronics, or apart from that, component designing, or to find the most possible path to minimize the total resistance and capacitance of the circuit as shown in the figure. Yes, these are the real world applications. So conclusion, coming to the conclusion of traveling salesman problem, that is, traveling salesman problem represents an pivotal challenge in optimization theory, with broad applications of spanning logistics, telecommunications, and beyond, that are manufacturing or supply chain, whatever. So, while the problem's computational complexity possesses formidable obstacle and plethora of algorithms, from simple greedy heuristic to intricate metaheuristic like genetic algorithms. So apart from that, traveling salesman is more efficient routing, that is, we could say branch and bound is not so efficient for finding the solutions in rapidly evolving technology landscape. Yes, here is the QR code to give your valuable feedback for us or presentation. How it is, please do scan here and give your valuable feedback. Yeah, thank you.